Dear students, welcome to Nivi's Patashala. In this video, we will be studying about deterministic finite automata. So in the previous video, we saw all strings ending with substring length n will require n plus 1 states. So if the string is ending with a length n, it requires n plus 1 state. Now if the string is starting with a substring, then it will require n plus 2 states. So if a string is starting with length n, we need n plus 2 states. Here we have an example. Construct a DFA to accept strings of A's and B's starting with A, B. So let us analyze the given problem. So the accepting strings are, the minimum string can be A, B. So A, B should reach the final state. I can have A, B, A. I can also have A, B and n number of A's because it is starting with A, B. I can also have A, B and B, or A, B and n number of B's. Here also it is starting with A, B. So it means my string has to start with A, B, and then it can have n number of A's and B's or B's and A's. It has to start with A, B, and then the DFA has to accept these strings. What are the strings that will get rejected? If it is only A, or if it is only B, or if I have n number of A's and B's, or if I have BA, or if I have AA, all these strings, that is, if the string doesn't start with A, B, the first two input cells of the string has to be AB. If it is other than AB, then all those strings should be rejected. So we need the length n plus 2 states. So here the minimum string is AB. The input symbols, the input alphabets are A and B. So the skeleton DFA we have here is Q0, Q1, Q2 and Q3. So I have length of the string is 2. 2 plus 2, that is 4 states. So here minimum string A, B is accepted. If my string is going to start with B, I have taken another state here. So Q0, Q1, Q2 and Q3. I have 4 states. So these are the transitions. Q0 on A is going to Q1, Q1 on B is going to Q2 and Q0 on B is going to Q3. We also have the transition table here. Now let us complete constructing the DFA. If you are wondering to loop B here instead of giving it to Q3, so it means what? If my string is starting with BAB, it will get accepted. So therefore, I am not looping B in Q0, I am taking another state for B. If I loop B here, BAB, which should be rejected, will get accepted. So I am giving a new state or another state B for Q3. So if I have A, B, string starting with A, B, it has to be accepted. So after A, B, if I have n number of A's and B's also, the string should be accepted, isn't it? The string is starting with A and B, and after that n number of A's and B's are also accepted. So let us fill the table also here. Next, if my string is starting with B, it has to be rejected, isn't it? If it is starting with B, or if it is having AA, or if it is having BB, all these are rejecting strings. So if my string is starting with B, and after that if it has n number of A's and B's also, it should not be accepted. So I am giving n number of A's and B's to Q3 itself. So if my string is starting with B, and after that also if I have AB, it should not be accepted because it is not starting with AB, it is starting with B. So I am looping n number of A's and B's to Q3 itself. Now if my string is having AA, if I have AA, it is not starting with AB, it is starting with AA. So it has to be rejected. So what happens? The first A moves from Q0 to Q1 and the second A is coming to Q3. If I loop that A here, what will happen? A, B will get accepted, which is supposed to be rejected, isn't it? So I am giving that A to Q3. 3. So here we have a dead state, we also have a trap state and a dead state. So this is the transition table. Let us write down the transitions. Q0 on A goes to Q1, Q0 on B goes to Q3, Q1 on A goes to Q3, Q1 on B goes to Q2, Q2 on AB is in Q2 itself, and Q3 on AB is in Q3 itself. So this is the mathematical representation. I have Q for all the states, Q0, Q1, Q2, Q3, and the input symbols are AB. The start state is Q0 and the final state is Q2. Let us take another example. DFA to accept strings of A's and B's starting with AA and ending with BB, which means the DFA should start with AA and it should end with BB. Let us analyze the accepting strings. So it is starting with AA, ending with BB. This is the minimum string and it is accepted. Here we can also see AA and then n number of A's ending with BB. So here also it is starting with AA, ending with BB. This is also accepted. Here again it is starting with AA, it is having n number of A's and n number of B's and ending with BB. So this is also accepted. Here also we have starting with AA, ending with BB, and in between there are n number of A's and B's jumbled together. Still it is starting with AA and ending with BB. So therefore n number of A's and B's can be there in between. So the string has to be accepted. If it is starting with AA and ending with BB, it can have n number of A's and B's in between. What are the rejecting strings if it is only A, B, or n number of only A's or only B's, or if it is BA, AAB, or any string that is not starting with AA and not ending with BB, all these has to be rejected. So the minimum string is starting with AA, ending with BB. The input symbols and alphabets are nothing but A and B. So let us construct the skeleton DFA. Here the length of the string is 4. AABB, length of the string is 4. I will be requiring 4 plus 2 states. So I will be having 6 states. That is Q0, Q1, Q2, Q3, Q4 and Q5. So here I have 6 states. Here we can see A, B, B is accepted. So the string is starting with AA and ending with BB is accepted. If my string is starting with B, it has to be rejected after a number of A's and B's also if it starts with B. So I have taken another state where I have given B. So if the string is starting with B, I have given another state for B. So let us see the transitions. Q0 on A goes to Q1, Q1 on A goes to Q2, Q2 on B goes to Q3, Q3 on B goes to Q4, and Q0 on B goes to Q5. So this is the transition table we have here. Let us fill this table now. So here I have the skeleton DFA. Let us complete this diagram now. If my string is starting with AA and then if it is having n number of A's ending with BB, it should be accepted. So I am giving AA and n number of A's to Q2. I am looping n number of A's to Q2 and ending with BB is accepted. Now if I have a string AA, BB and then if I have n number of B's, here AA or n number of A's, BB and then n number of B's also means it is ending with BB. So Q4 I am looping B's to Q4. So if I have AA, BB, n number of B's is still in a final state. Now if my string starts with B, it should be in a non-final state because my string has to always start with AA. After that it can have n number of A's and B's and end with BB. So here the string is starting with B. So if my string starts with B, after that n number of A's and B's also should be rejected. So if my string starts with B, I am giving it from Q0 to Q5 and I am looping n number of A's and B's in Q5 itself. So if my string starts with A, B, then it is supposed to be a rejecting string because it has to start with A, A. So if it is starting with A, B, I am giving that B from Q1 to Q5. So if it is starting with A, B, and if it is having n number of A's and B's, it is in Q5, which is a non-final state. If my string is A, B, and then if I have another A, instead of giving it to Q5, what I can do is I can give that to Q2, where Q2 is also a non-final state. So if my string is only A, B, A, it remains in Q2, which is a non-final state. But if my string is A, B, A, and if it is ending with B, B, so if my string is A, B, A, ending with B, B, it goes to the final state. What will happen if I give that A to Q5? From Q3, if I give A to Q5, A, B, A, and then n number of A's and B's, even if it is ending with BB, it will remain in Q5, which is a non-final state. Therefore, I cannot give from Q3A to Q5. Now again, if my string is having A, B, B, then if it is having A, what I will do? I will give that A again to Q2 because it is having the same condition. If I have A, B, B, and if I have an A, I am giving to Q2. And after that, if my string is having BB, that is if it is ending with BB or n number of B's, it will reach the final state Q4. So this is the completed transition table. So here we have the transitions. Q0 on A goes to Q1, Q0 on B goes to Q5, Q1 on A goes to Q2, Q1 on B goes to Q5, Q2 on A loops to itself, on B goes to Q3, Q3 on A goes to Q2, Q3 on B goes to Q4, Q4 on A goes to Q2, Q4 on B loops to itself, and Q5 on A and B is looping to itself. So the mathematical representation for the DFA, we have all the states here. Q is equal to all the states Q0, Q1, Q2, Q3, Q4 and Q5. The input symbols are A, B. Q0 is the start state and we have only one final state, that is Q4. Thank you for watching. Don't forget to like, share and subscribe.